Good evening, everyone. Um, I welcome you to this meeting today. Mhm. Yeah, we have our speaker here, and we have a lot of people here as well. I would enjoy you to please share the link to the meeting so other people can join. So we are going to start now. Yeah, I was waiting for more people to join before we start. I'm Bushro, and I'm the co-lead for the cybersecurity community, GDG. So today, the topic was actually picked based on the fact that a lot of people build applications and then they think security is actually the afterthought of building an application. And a lot of vulnerabilities has been in existence for a very long time now, but then they are still you can still see them in a lot of applications. There are some applications that when you test them, you're going to see very minute kind of vulnerability, something that is not even meant to like be there. But then the question now comes to, is it about the fact that people are really not aware about this vulnerability? Is it about the fact that people don't know much about it, or they don't know about the security aspect of building a web application or a mobile application, because the web application and mobile application has their vulnerabilities. Yes, so that was what brought about this idea of a collaboration between the web development community and the cybersecurity community. How can we bring the awareness of people to, okay, these are the kind of vulnerabilities you can have in a web application, these are the kind of vulnerabilities you can have when you're building an application, and not just something that a security analyst must be present. A security analyst will be present to be able to make sure your application is well secured, because security starts from the code. When your code is not secure, then definitely there's vulnerabilities in your app. The vulnerabilities they are having are not as a result of maybe someone put it there or anything. It is as a result of your code. Is the way you code and how you write your code. Those are what's bring about the vulnerabilities we have in applications. So that is the reason why we are holding this webinar today. For us to know what are the things, what are the vulnerabilities you can easily you can easily um what are the vulnerabilities that we can see in an application, and the way you can prevent it when you are coding? That is the secure coding technique. What are the secure coding techniques you can put in place to prevent these vulnerabilities from existing in the application? So that is the main focus of today's webinar. And with me, we have before we move to the security aspect, we're going to start with the with the software engineering aspect. What are the things you have to know about building an application? What are the things you have to know about secure coding? So before we move, before we can secure an application, they must have built the application. So that's why I'm going to start with our first section, which is going to we have our speaker here, Mr. Bukola Lawrence Taiwo, and he's a software engineer majorly specialized in the backend development. And I love that because most of the vulnerabilities are backend vulnerabilities, most of them. We have vulnerabilities that surface from the front end, but most of the vulnerabilities we have are from the backend. So he specializes in backend and in fintech and app security. That's nice. So yeah, so he has experience building scalable financial systems and secure web application with a strong focus on secure by design development practices and modern software architecture. Yeah, I'm happy that it's actually an app security as well. Like seeing things from two different sides, from being a software engineer and also an application security. So I'm sure we have a lot to learn from him today. Okay, so that will be our first speaker, and we'll be having our first section now. Over to you, Mr. Lawrence. Hello, can you hear
Oh,
me?
yeah, I can hear you. Can you hear me now?
Yeah, I can hear you. Thank you for joining the call.
All right, you're welcome. Good evening, everyone, and
Good evening.
thank you for having me. It's really nice um, being with you guys, and really appreciate. All right, so let me share my screen and not to waste our time. Um, yeah, please, can everyone see my screen?
Yes, sir. Yes, sir.
Yes, you can.
Yeah. So, first of all, my name is Taiwo Bukola. I said earlier. So, I currently work with Money Point as a senior software engineer. Um, the the greatest mistake engineers or software engineers make is why building an application is thinking a security is an afterthought business. So, but why not putting the security first? So, if you are building an application and you tend to overlook the security aspect of it, you will have yourself bites to bear the consequence. And this is because I've been fortunate to work in the financial sector, um, and I've built systems that moves money and not just even local currencies. So prior to me working at Money Point, so I used to work with EcoBank. So and I was part of the team managing the rapid transfer engine. So that is the engine used by EcoBank in moving money across their 33 affiliated countries. So you can think of it as a switch system that move money, like somebody sending money from Ghana, like you said, it's Ghana cedis. The person want to send it to a Nigeria account, or all those things, or multi-currency systems. So if you're building a system and you now think, okay, let me build a system, and after a while I will handle the security, or I will get the security expert to look at the application, it's going to be so messy. So the first thing you think of while building an application is what are the mechanism I need to put in place to make this application secure. Because to be truthful, everybody make mistake, but there are some mistake that you made that will really lead to a big loss, either lead to a big loss or even a loss in reputation. So, and I just think of it, you build an application that has not even make money yet, and you're already losing money. How will the the business people feel about it, or even you as a developer? So, and people look for your loopholes. Let's say they try to check, okay, how can they take advantage of the system, not even on the like a normal fraudster, like in all those hacking groups, but even just ordinary user can decide to gain your system. I've made a mistake before, and okay, there was a system I built. I was the lead engineer on the project. So the the junior engineer did an integration. So, and the engineer make a mistake. The mistake was that while trying to integrate the external API, the she used an integer, that is a primitive int, which defaults to zero, right? It defaults to zero, and and the actual response actually from that API is supposed to be zero as successful. So zero as successful, one as failed. So since it defaults to zero, we won't be able to know if the actual transaction that was performed is really successful. So when the money was pushed and a transaction failed, or they did not send any value for that feed, it keep defaulting to zero. So we keep not in money points. So the solution was not in money points. So it's one of my gig that I worked on. So the we paid the customer without debiting the customer's account in that scenario. So because the API was just returning zero zero, and a customer was able to get hold of that and try to gain the system. So it's the fraud system that actually picked that up. So, and the limits, that actually help us to limit our exposure. So that is so let's assume that we did not have a limit system, or there's no fraud system that is running to pick up if there's any anomaly on the system. We will have lost millions of naira before we detected the issue. So this is why when you are building a system, you don't just build that okay, everything is going to work fine. You build a system with security in mind that anything can break, anything can happen. If this thing happen, what is the way forward? And how can I even prevent some known security issues? There are some known and there are some unknown security issues. So how can I prevent these known security issues? And if unknown security issues happen, how can I detect it early? And how can I mitigate it? All right. So my agenda today will be we're focusing on this, talking about secure by design, the modern architectures, authentication and authorization, the API security that are currently being invoked in the industry, secure SLDC, that is software development lifecycle, CI/CD and cloud infrastructures, and a practical checklist of um, all the what I've mentioned. Okay, so first of all, let me start with the modern web architecture. So currently, as of today, the normal OSI layer movement, right, moves from a user um, a user of a system. Let's say you as a user, you want to use a mobile app, or you are even on Facebook, you want to use a Facebook application or anything, or even on WhatsApp, right? It has a front end, and that is what the user actually interface with. So the security itself starts from the front end and up to the your storing layer, which is the database. So the front end, the as of today, the normal layer is this. The front end collect the inputs. It's passed through an API gateway. There's an authentication server or a service before moving to the services that actually route the all the processing are moving into database. So and from all these points, there are various places that there can be a security breach, right from the front end to the API gateway to the to the authentication service itself and the other logical service and even on the database. There are different security risks in each of them. Please, are you guys following me?
Yes, sir.
Oh, all right. So, and secure by design. So when we're building building an application, you have to think of it starting from your design, the coding, the testing, the deployment, and the monitoring. Everything you have to think of the security in every part of it. When you are designing it, as I said earlier, we have identified that these are the various uh, points where there can be security breach. Now we say, okay, on front end, how can I secure any security risk that can happen on the front end? Some of the security on front end, cross-site scripting, impl validation, all those things. But even likewise, as the front ends are exposed, the back end are also not safe from um, security breach. Even most time, most security breach happens on the back end, right? So that doesn't mean it doesn't have one front end. So all of them are exposed. So, but once someone gets hold of your API that's currently being used by your front end, and they are able to get hold of all what the system is doing on that bit, you're highly exposed. Uh, let's move to authentication and authorization. So, when talking about security, first thing I would say is your validation matters, right? And the validation, when I'm talking about validation, is this: your user is expected to provide a email address. I created an API. The API is used by user to sign up. How can I even ensure that the value that is being provided by the user on sign up is actually not an invalid, that the user is not providing a the value that they are not supposed to provide. Example, I'm expecting you to provide an email. My email should not be accepting a phone number. And there are some keywords also in that is known in industry that also expose you to security risk, like allowing asterisk, allowing slash, all those things they can use it to do. There's something called SQL injection as part of the security um, threats as of today. So whereby an attacker can inject in your through your inputs values, they can pass a value that can break your code or even be able to override your script. That means your SQL script. So let's say you allow a user to enter asterisk, and when they enter it, you collect it, you use it to run your SQL. At that point, you might be exposed. So you have to ensure that every validation, every request coming into your system is validated. Are they passing an invalid value? Is the person passing the right even feed in the first place? So all those things are needed to be done. And also the second thing is now the authentication and authorization, which, as I said, the authentication, who are you, right? As we all today, we all live somewhere. Let's say I come to your room or anything, and I knock on the door of your room. The first thing is what you ask is, who is there, right? You don't Nobody just open door for someone that, or you can't just be like somebody knocked on your door and just be like, come in, right? The standard process is you hear a knock, you ask who is there, right? And the question who is there, what you're trying to do is authentication of it. Like, okay, who are you? Like, did I know you first, right? So also on the API level, you need to first identify the person that is trying to call you, right? Does this person have the right to call me in the first place? So today you can open any application, right? Even let's say WhatsApp today. When you are creating a WhatsApp profile, the first thing they ask you is provide your email and phone number, or you sign in through your using your phone number. At that point, what they are trying to do is, who are you? Do we know you? Have you signed up before? Then if you are signed up before, they say, okay, yes, we know you. Then they allow you to go in or to process any of those anything you want to do on the application. So, and the second bit of it is now the authorization. Now I know who you are, right? I've knocked on your door and you said, okay, who are you? I said, oh, it's me, your friend, Bukola. You'll be like, oh, Bukola, it's you, right? Come inside, right? You've allowed me inside. But because you allow me inside, it don't mean that now I have rights to everything in your room, right? So that doesn't mean I can just say, oh, guy, Alpha, just go to your kitchen, pick food in your kitchen, or go to your wardrobe and pick your clothes, right? Even despite that you've allowed me into your room, I have limited access to things in your room, depending on our relationship, right? Or depending on the roles that I am in your life. Let's say if you are cordial friends, I might be able to go into your kitchen, pick food, or go into your wardrobe, pick a clothes, right? But if let's say I'm just your course mate and I just come to say I'm someone that is just talk to once in a while, so the person can't just go there. If the person even stand up, be like, where are you going to? You don't have the right. Why will you go into my pot to pick food? You get. So that is the same way authorization also works. It answer what can you do, right? This person has login, but can this person have access to my admin features? Can this person have access to fetch other users details? Can this person perform transfer, right? So that is what the authorization bit talks about. And you need to know something: never trust the client side. That's one of the great mistakes that people software engineers or backend engineers actually really used to make. Like, okay, no, why will I need to validate the price being provided by the front end, right? The user has already selected the price now. So I've given the price to you. Why will I need to validate the price again or fetch the price on my side? Just pass me the price. Okay, for example, now you go to Jumia website. You want to purchase an item. You saw on the website that okay, there was a shoe, an Adidas shoe, and the shoe is being the cost price for the shoe is 5,000 naira, and you see 5,000 naira, okay, and the 5,000 naira has already customer is already saying the 5,000 naira. So on the API level of things, you as an engineer, putting security in mind, you don't ask them to provide or you don't rely even on the price. Let's say your endpoints have what is it called? Give me the product code of the shoe, right? Product code of the shoe, and give me the price of the shoe. But you don't use the price, and the person has said, okay, you don't deduct the price from the person's card based on the price provided by the client. So what you do is you use the product code to fetch the price on your end. So a user can determine the price because there can be a man in the middle attack in which, let's say, someone have access to Jumia raw API and the person is able to know, okay, this is the endpoint that Jumia is using to actually purchase to deduct for my card, right? And at that point, you know, guys are now kind of, wise these days. So there are different tools they use. So they can, at the point, send a different price from the front end and intercept the request and change the price. Let's say the price is 5,000, they can change the price to 1 naira. And if you are using the raw value coming from the front end, right, from the client side, and you are using that to process the transaction, you will deduct the person, you deduct one naira, right, instead of 5,000. And in that place, in that scenario, you will have deducted 1 naira and you will have told the user that okay, successful, and they will have released the goods, right? But if you are doing your validation and you are not relying on the client side, what you do is the product code itself you fetch from your system. What is the actual product from my database? The product price. Then you use that price to deduct from the customer's account. So don't blindly trust the client side. So common developers mistakes. One, trusting client's input. So as I said earlier, blindly just be like, oh no, um, I've returned it to you before, return it back to me. I will use it like that. And also missing validation, whereby you allow the person to pass in any value. You are requesting for a feed for an integer or for a numeric value for a price, but you're allowing the person to pass in a string or an alphabet. That is totally wrong. With that, you are not doing enough validation on your end. Also, another one is hard-coded secrets. Yeah, this is one of the bad behaviors I've seen amongst engineers, especially junior engineers. Like, using hard-coded secrets. So let's say you're trying to build a JWT token, which require you to have a key, right? Your signing key. So, and that key, sometimes some will put it inside the code base and hard coded it. It's a bad practice because which means if your code is exposed, your system is exposed, right? But the normal standard way is when you're having some values that are essentials, you don't put them on your code base. Even as of today, GitHub Guardian, it will even flag you, like, let's say you are pushing it, to flag you, will tell you these are secret code. Why are you putting it on your code base, right? But some people still go ahead put it on the code base, or some they will just put it on their application property file or any of their env files also. So what where you store your secrets, you store it in vault, right? There's something called vault. A vault system is just like the same way in normal system where you have vaults. In banking, vault is where you store uh valuables, right? Where you store your money, where your savings. Today all the money inside bank, you go to a bank, a branch, or any banking hub, all the money is stored in a vault. So it's at the beginning of the day that they bring out the money from the vault to the cashier, that the cashier, and so at the end of the day they have to return the money back to the vault, because they believe that the vault is the safest place to keep valuable things, whereby someone cannot just come, fire cannot engulf a vault, uh, anyone without authorization cannot enter a vault, right? So that is the same way also in software engineering. There's something called vault, a vault system. uh there are different providers of even vault system. So we are, even AWS have their own vaults that they provide that you can rely on. And also the using of env5, that is you're putting it as an environment variable, but not hard coded on your code base. Never ever hard code secrets on your code base. The next one is logging of sensitive data. So these are situations whereby sometimes we feel like we want to make things for debugging purpose, we want to make it easier. I want to log all the requests and response coming in. But are those requests and response, are they sensitive data? Now you are logging someone's card details. You are logging someone's card details, you log the person's PIN, or someone is logging in, you are logging their username and password. Do you trust your monitoring team, or somebody that if somebody have access to your log, the person can go ahead and spool out all those data and use it to log in, right? Also, weak password hashing, right? So these are situations whereby you are not using the right hashing mechanism, right? You are using SHA-1, or you are using a weak, even let's say some people that use encryption, even though that is not even uh best practice to use encryption for password, and you are using let's say CBC algorithm, or you are using even AES GCM that is not without no padding, that allow padding and all those things. So you have to ensure that all hashing mechanism that you are using is top notch. Yeah, moving to API security. Sorry, hope I'm not too fast, and I hope you guys are still following up with me.
I'm following you, sir. I'm following you, sir.
All right. So the API security itself, I've discussed input validation. Another bit where most people overlook is their rate limiting. Attack, when they say there's a security attack is not just about losing money or losing funds or even losing user detail, right? Some attack are kind of like people trying to overload your system, right? So there's a name for it, I really forgotten. So the someone can have access and try to even exhaust all your resources. So they just want your system to go down. So with that, they might write a script to keep eating your API. So let's say they write a script that bombard your API with 1 million requests per second. And the 1 million request is coming constantly, which means even the user that was supposed to use your application, they won't be able to use it, because there will be heavy traffic. Your system will start because having low throttle, that means low response time. Before you know, this whole system will crash. So you have to protect your system against those kind of attack, whereby someone is just trying to eat your system, or even some people even create hackers create bots, a bot that will just keep eating your API, trying to do different things that is not necessary. So you rate limit your API, and what design by rate limiting is minimizing the number of calls that comes that an IP is allowed to make either per seconds or per minute. Most of the times is set by seconds. So which means you are saying, okay, I want this endpoint to only allow 2 requests for a same IP address. If the same person is making more than 2 requests per seconds, ask the person to wait. Like you can give them a waiting period, like let's say a waiting period of 5 minutes. That's okay, so that will give chances for other users to use the system. It won't be like somebody is only one person is holding the resource. JWT validation, and so JWT validation is talking about your authentication layer. Those are part of authentication mechanism. So we have different mechanisms we currently use. So JWT BRR token, OAuth 2 server, API keys, basic codes. So JWT validation, you ensure that you are validating your JWT. When you are using BRR token, you should not allow an expired token to access your system, or you should not even allow your essential APIs to be exposed to the internet without proper security. That's one of the greatest breach. You create an API to do a transfer, and that API accept anything. Nobody doesn't require you to authenticate. He doesn't even want to know you. Just come as you are. Make the call to it to perform the transaction. That is a really bad practice and a bad system, right? You need to ensure that all your systems are all your APIs are behind security, right? Which means they have to be authenticated before accessing them. The other one is in idempotency. So idempotency helps you in the process of deduplications. So whereby someone is performing requests multiple times, especially in the case of building a transfer or transaction system. You don't want a situation whereby, due to, let's say, a customer click on transfer now, they've entered something, they click on transfer on any system, but because it's taking time, the user keep pressing transfer, right? Your system should not be built in a way that because the person is click on that multiple times, the person is trying to set 2,000, you now deduct 2,000. Let's say in the person only have intention of sending 2,000, but now you've deducted different 2,000 from the person's account. Idempotency help you to help on that, so it protects you against the duplication, like the person making duplicate requests every time. Audit logging, audit logging is one of the most essential things you can use, and this is an afterthought, right? What you use for after that you can help you if there's a security breach. If there's a security breach, audit logging helps you, because that's where you will say, okay, who made this request? At what time did they make the request? Which IP did they make the request from? Right? What was the request that was made? Those are auditing your system. So it helps you to identify where the breach is coming from, and you can know what to focus on. Example, someone built a system that has now been exposed. You need to know what is being exposed, right? Is your audit log, you check your audit log and you see these are all the event that has happened. Where is the event that is exposed, and how can I mitigate it, or how can I even follow up in the recovery? So that helps you. TLS, TLS everywhere. So what TLS means, it's a transport layer security. So you will say most time they'll be like, whenever you are accessing an endpoint or a web browser or any URL that doesn't have HTTPS, right? That means the URL lack TLS certifications, right? That means the API is not secure. And because there are different security threats, There can be the one happening on the network layer, right? That means somebody intercepting all the requests going on the network layer, and the person maybe decrypting the request before letting it go, or intercepting and changing the request and sending his own request to the system. But with the help of TLS, when your endpoint is being protected by TLS, uh, a strong TLS, not even, we're not talking about TLS 1 now. So a strong TLS starting from today is from TLS 2, even TLS 3 now. So when you are using that, what happens is on the network layer, if the person, let's say the person is sending username A, password B, right? On the network layer, what the TLS does is it helps you to scramble those requests to a non-readable format, something that is not readable, and if somebody have access to it, they won't be able to see what the actual value is. So that helps you to protect against threat on the security layer. The about this, so the third party and CI/CD security. So when you are consuming an external APIs, right, and one of the things you protected yourself is first against on your request and your response, right? Ensure that your response come that you are returning is not having a default value, right? It's having the right value that you can use to make decision. And when you are working with a third party that sends you webhooks, you don't blindly rely on the webhooks. When you receive a webhooks, the first thing you do is to check the signing. Most webhook provide a signing of the request they are sending, and that is to ensure that somebody is not sending you a response that is vague, right? So with that, you can check, okay, has this webhook request been tampered with? You can use the signature that was being sent to check that. That is to avoid that somebody is not passing a vague or an invalid request to you. Also, stop secret securely, dependency scanning if you are building a system. So there is one of the tools you use for dependency scanning today is there is SonarQube. SonarQube does security test scanning and dependency scanning. So it tells you to actually check, is there any vulnerability on your code? I think early this year, I think it was February or March, when they detected that there's a version of Arceus, that is a JavaScript library, that was vulnerable, right? So all those things, if you are using a CI/CD security, it helps you detect if there's any flag in any dependency that you are using or any libraries that you are using. It helps you. Also, static analysis, whereby there is a constant analysis of the system, checking what is going on the system, and a least privilege. Yes, this is essential. Ensure that a user only has a privilege that you need to perform a particular action. You don't just give them a wide overall privilege, like, okay, come, you can access anything. No, let them only have access to the minimum things that they are doing. If they are performing a transfer, give them a transfer privilege. If they are performing a name inquiry, give them a privilege to access the name inquiry API, not give them all the privilege to access any of your APIs. Yeah, also, I know my time is really fast spent. One of the things is encryption of data too. You are to rest. If you have sensitive data, you try to protect the data on a database by encrypting those data. You don't just assume that, okay, my database is sitting my in-house. What if someone make a mistake and your cloud infrastructure is exposed, right? In that scenario, if there's any breach, none of the data will be useful by the person that have access to it if it's encrypted. And also monitoring and logging. These are after you build the system, ensure that the system is being monitored. Ensure that there are metrics that you are checking on every time, that is checking, okay, is there a spike on the transaction? I normally do transaction on my system. My system always process, let's say, 200,000 in a day. But now you suddenly see that there's a spike on your system that is now processing millions. You have to first your money system should be able to flag that for someone to come and check it, like, okay, is there everything working fine? uh am I is not somebody not trying to use me to bypass AML check and all those things for money laundering. Yeah, so with this, I think I will go to the questions. Yeah, if anyone have questions that they wanted to ask.
Hello, sir.
Yeah.
Good evening, sir.
Yeah, good evening.
My name is Izzy Benjamin. I'm Izzy Benjamin from Lagos, Nigeria.
All right.
Okay, yeah. Also into software engineering too. I'm 15-year-old, don't mind. I'm also into software engineering. I was fully based at front end development, but I'm done with that. But I'm into AI and machine learning. But what would be your advice to someone that lost access to his laptop because of this thing has really put me down? Like, what would be like your advice to the person? Because of most of this thing, I can't really do it on a phone because of the laptop I was using before got bad. So a friend of mine gave me his. So he had to collect it back. So it slowed me down. And so it hasn't been easy for me. I even have some bunch of projects that I've hosted online using my GitHub. Some website I created that has my name on it. So I still have them with me, some of the links with me. So what would be like your advice to them? Because it hasn't been really easy. I'll meet you here at machine learning.
All right. That is really nice. So it's actually good to start early. You are not too young to start as an engineer. To be frank with you, there are a lot of people that are younger than you that I know one of my boss that's his child started coding at the age of 6, 7. So you are not too young, and keep it up. And on the computing bit of it, so I remember when I started too, I did not even have a laptop. When I started with phone. I was uh, I was able to get some ID then, so I was just trying to. Although it's not as easy as when you're on laptop. There are some phone IDs too that you can actually use to run some of your code that you can use as of today. You can try to use that too. Some of us have good phones that we don't even know uh, that can perform some of these actions, like some of these programs that we run on the normal laptop. You know that even as of today, there are phones that support you using mouse or and even using keyboard. You just turn your phone to monitor. So if you have that privilege, you can use that too, and don't relent. There was a time whereby people were learning coding using paper and pen. Yeah. So now we are just fortunate on this digital age. There was a time people they will write the code like you are writing notes. So they weren't even able to compile it, able to run it. So just think of it. So if they could stay do it that time and stay successful. So why can't you use your phone? So just try. You can use your phone, and anytime you have access to a laptop, you can quickly work on it and push it to your Git up repo. So that would be
Okay.
my advice.
Well, thanks, sir.
Yeah,
Yeah, you're welcome.
thank you very much. Thank you very much. So every other question can be posted to the comment section and then we'll pick it up from there when the fireside chats begin. So yeah, thank you so much, Mr. Tayo Bukola, for such wonderful session. It was like really, really insightful. It was really insightful. So good evening, everyone, and welcome once again. My name is, for people like I didn't introduce myself earlier. My name is Ezekiel Fabule, and I am the current GDG OUU cybersecurity team lead. My co-lead at previously introduced herself in person of Bushra. So, as we all know, what tonight's webinar is for is talking about building secure modern application. We are looking at is from like both a developer and the cybersecurity perspective, which Mr. Taiwo Bukola has done some justice to. So, to the other parts of the webinar, I'll be introducing a very fantastic person, a person I'm going to call my mentor because he's one of my mentor in this field. So he's the one that's going to be walking us through the cybersecurity part, and that is no other person than Mr. Emmanuel Awe, popularly known as Coco Felon. He has deep experience in web application penetration testing, mobile application, malware development, and the likes, and is going to be taking us through this session. So, Mr. Emmanuel Awe, the floor is yours.
Good evening, everyone. Good evening. I hope everyone is well. Um, Previously stated by the uncle, I think my alias that most people would find me easily by or would get to know me by is Cuckoo Felon. And I think it's a funny niche name. It's a niche name that those who know it. Those who don't, they don't. But it's a niche name in the cybersecurity realm. I think first of all, I think for the theme that we have, it covers a thought that I've always had around the OWASP top 10. And truth is, I don't believe in the OWASP top 10. I think it's shit left to me because the way OWASP top 10 is being taught is not the way it should be taught. Honest truth is, when you cut across web API and mobile penetration testing, there are some things that you would begin to see differently. Several types of bugs, several types of vulnerabilities that you find. And honestly, there is not a word or a phrase in the OWASP top 10 that can actually give us a
Actually
grasp.
give us a
Sorry? Okay. That can actually give us a grasp of what that bug is. You find bugs in the weirdest places, if I'm being honest with you. And as much as the software engineer here can do his best, the best, like no matter how much you can do to secure your systems, truth is there would always be that funny thing, there would always be that funny aspect of the system that would it will just trigger something funny. It's a very, very funny very, very funny place to be. So I think that's why I would dive more on tonight. The OAuth stuff then goes around the uh SQLI and XSS. Those are injection attacks. You have session related issues. So I think from a security perspective, I would prefer that we take the OWASP top 10 not just as OWASP top 10, but like as a concept. So every part of the OWASP top 10 is a concept on its own. If you're looking at injection attacks, SQLI, XSS, and the likes, even though I rarely see those in applications these days anymore, because they are libraries that are built specifically to handle and maneuver around XSS and SQLI. But still, you can't exactly throw it in the bin. We call them injection attacks. So that means that wherever you can inject something and you are able to get a positive response from your injection in the application, that's an injection attack. Insecure direct object reference, that's IDO. A very, very funny bug that grants you access to another user's information just by switching a digit or switching some numbers. Very, very interesting bug if you are being honest. But the truth is, how often will you see those in the day-to-day application? The same way it is taught online, same way it is taught. It is thought to be very, very easy, but in reality, you have to think in different dimensions and contexts. And I think the software engineer would agree with me that softwares are developed differently. the architectures behind each software is built differently. So if we are looking at, okay, we have this architecture, we have the architecture, you can't exactly go into every single application with the same mindset as the last, because each one carries a different architecture. Each one requires a different architecture in order to manage it. For example, if you are writing something that is a monolith type of code, over time, yes, it can help you serve and start your processes. But every software engineer that is what it will tell you that at some point you have to break those monolith processes. Sorry. You have to break them down into uh microservices. So you're breaking every single part of your system into a tiny unit that can run and function on its own. That way, even if there is an error, even if there is something that goes down, it's not the whole system that goes down. It's in the case of applications that maybe where you are supposed to put a letter, the user put a number. The next thing you know, the whole application is down. That's a denial of service already. So that means that if any hacker wants to just tamper with you or fuck with you, all they have to do is just go and shut down the system at the peak moment with that particular bug. And you have hundreds or even thousands of users waiting for the service or even losing their money in the process. So I think, does anybody, can we all hear me? So I think it's a smart idea that we don't look at the OWASP top 10 as just a checklist, but as an ideology on its own. Because when you begin to see these ideologies on their own, you now begin to see the web application more. Now, where I'm not driving to is this: for every web application that you have, it has a front end, it has a back end. No matter what, there is a front end, there is a back end. Somehow, that front end and back end needs to communicate. Hence, we have what? API. Sometimes API is the back end. In some cases, API is back end. In some cases, API is not the back end. In some cases, API handles just routing. But in every single scenario that you can find of web application, we have the front end and we have the back end. The front end speaks to the back end. The back end sends information to the front end. They are married to friends. Fine, API can come into this scenario now and ease the function of the back end. But the core of everything in web application these days is a front end and a back end. These two are very, 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 very important in technical whatever websites are you developing. You develop a web application today, those two must be there. But we're now going to explain why seeing them from a higher perspective is very, very important. Now, we need to understand something. The software engineer said something about logging. Now, there are many reasons why logging can put you in trouble. And I'll give you explanations from the aspect of someone who has experience in this kind of situations. I work mainly across the financial sector and industry. So I can't even count the number of fintech that I have worked with or worked on. Not even fintechs, banks, amongst others. So when I speak, I think I'm speaking from a place of knowledge. And I'll tell you that the things that you least expect to do you any harm can actually come into play. For example, when you are deploying your website and you need the user's location, some way or the other, you would need to use a Google API token, at least to be able to get their location and send it to wherever you need it to go. But somehow you will need to call that particular key. Now, what we don't know is that the key in itself, Google API key in itself, shouldn't be dangerous. But then it cannot be weaponized against you in manners that you never expect. Take for instance, you deployed your system and this function of that key somehow is such that the system requires that API key to get your current location and forward it over for login or something purposes. So yes, that one is it's a harmless thing to do. But then you forget that that key also has permissions. So now what are the permissions on that key? Those permissions cannot be properly exploited. So that means that if you are looking at only location, that means that if your token is built for only location and you now begin or you now deploy it and it's now working for things other than location, you have a problem on your hands. This is the real world entity that I have faced. A real world deployed application whose tokens can be used to generate accounts, which accounts can now be used to access customer information. So that's why I said you can't box the things that we find in security into the OWASP top 10 or say, okay, these are the checklists that you must use because security is not a checklist. If you think about it, a token in itself should not be dangerous, but could it be weaponized? Very much. So this goes. That's why I said. That's why I always preach that whenever you're dealing with web applications, you need to think about every single aspect of the web application that you're dealing with. And like the software engineer rightly said, on the front end, we often have people leaking secrets. In the front end, we have people leaking secrets, and oftentimes than not, my methodology is very simple. If I'm entering your application, the first thing I'm doing is while I enter the website is to go through your JavaScript files. Plus, the era that we are in, that people now vibe code a lot. Vibe coding is not well. If left to me, I won't call it a danger. I'll say it's only dangerous in the hands of those who don't know how to use it. But I look at it that many of the newly developed technologies that we are using these days, they don't capture the real reality of whatever we are doing. And this is what I mean. You are looking at a web application. You have your front end, you have your back end, your API is there, everything is running fine. But nobody tells you that look, where this API, front end and back end meet, those junctions have things, they have things that they speak to each other. Front end sends requests to the back end. What is the front end sending to the back end? How is it sending it? Now I check your front end JavaScript files, and it is common amongst the latest JS versions now, React and the likes. It's not only React, I think there are a couple of others. You just bundle your app and you just send it over to the web. But it doesn't tell you that look, so key is inside the front end. And it's funny because keys are so distinct in the to the point where even you might not even know. Some of these also keep your keys in the places that you never expect. You can imagine that you are doing everything possible to make sure that you don't have leakages in your system. Meanwhile, it is the language or the framework they are using to compile and write the system or software that is leaking um that is leaking tokens or leaking your secrets. And like the engineer rightly said, yeah, you can keep your stuff in an environment variable, but I would also prefer that you keep your stuff in a vault because, to be told, it is not so hard to break into your server. I think you can secure it as much as possible, but there are many vectors that come into play. How fast can you patch a 0 day? A 0 day or not authentic or not. We call them on off. On off are basically exploits that you can carry out without an authentication. So that means that you can carry out an exploit where you're authenticated and where you're not authenticated. So imagine something, a random person that just comes to your server can just break in. That's what we call on off. So you now have these um you have these frameworks exposing tokens in the front end. So this is a very, very big flaw from the front end. Oftentimes it happens that people don't even know. Your front end leaks more than you think it would ever leak. So when we watch, so that is one of the key points to watch out for. So I'm taking you through how you should view the application to ensure that you are maintaining maximum safety, even down to the smallest unit. Now, if you are going to send anything to the server, you are either sending a post, put, or patch request to the server. It can't be all three. And if it is all three, you now have another leakage on your hands. So now you're now looking at, what is my server expecting? What should I send it? And my server, if I send it something else, what should it tell me? So now it's not only user requests that you look out for, if I'm being honest. Your user request might not be harmful, but the header behind it is harmful. Putting a put request in place of a post can harm your system. Now, how are you passing data? You can pass data with your JSON body. That one is not an issue. You can pass now. The where I now often have issues is where people pass data via their URLs. You click A, you click B, and next thing you are seeing your option on the URL. Depending on whatever it is, that's why we also advise threat modeling and security architecture. Because any sensible security architect will tell you that in the banking and finance sector, you don't tamper with anything that goes in the URL. At best, you can send a JSON body. Now, the API now handles requests coming in and going out. API should also be very, very watchful. Okay, what is coming in? This thing that is coming in, it's in the allowed list. Even if it's in the allowed list, how is it going to work? Should I allow it in? Should I not allow it in? Those ones also count. Now, you now come into the server or you come into the backend. What is the logic like? The logic behind this thing, is it airtight? Because believe you me, most of the binary expectations that we see out there these days, they come from the idea of math. And the math is not always that hard by the time you begin to reason it. But it comes from the idea and logic of math that requires that the logic that is there beforehand is airtight. Else, this particular parameter will break the system. That is the core ideology of binary exploitation. And it happens with one of the most crucial and most ruthless exploitations you can find. Most of them result in DOS. So we have to keep looking out for these things one after the other. This is why I said you can't put security in a checklist. You can't put it in a checklist. If you try it, in the end, you have yourself to blame for it. But what you can do is that at every segment of your development or of your system, you put in a very close thought as to what goes in and what comes out. Because the origin of all computers is 0 and 1. Binary. Off or on. Good or bad. Once you understand the concept of zeros and ones, good or bad, you are now able to now look at your system. This system is meant to collect data, return data. As at that unit point, you can now trace model by yourself. Okay, oh, if I do this, what should it do? If I do this and it doesn't do this, what should I do? You should have serious error handling to prevent your errors from now being serious vulnerabilities. For example, one of the funny things that we do is called user enumeration. I will intentionally send a wrong username to your system and a correct username, and I'll see what you will say. Incorrect username will say account not found or something something. Correct username will say wrong password. Now I know how to find usernames on your system. Then we also I think the software engineer also spoke about um how do I put it? He spoke about I am rate limiting. And the only thing I would like to add to what he said is this: instead of rate limiting IP addresses first, at app level, why not rate limit to the entity? In the sense that if somebody sends you a request, I want to log in as Ayomide, you should only allow the entity Ayomide test its password 4 to 5 times, not the IP address, because I can change the IP address, not the origin header. Because every single thing that you can imagine that is coming from the client. And like you said, you don't trust client side. So that means that whatever you think that the client side will give to you, that you can use to identify me, I can nullify it. But the one thing that the client side cannot give the server is the correct name. If it's the correct name, it's the correct name. So that's the one thing that you have control over, making it easier for you to rate limit them. Now, if the user doesn't now exist, you can now go back and rely on the IP address rate limiting. This way, you now have defense in depth down to their account. So even if somebody is trying to hack somebody's account, between 3 to 4 tries, the account is on hold. So now you can't just randomly go and splurge passwords at anybody's account again. Because even if you decide to use only IP address, you can ban one IP address, but in the network there are about 200. I think the cybersecurity students here understand what I'm saying. There are about 244 different IP addresses that you can in a subnet. That means that over 100 IP addresses are available for you to use at a particular point in your subnet, because it's your home network. It's now dependent on the DHCP. So once you understand that you can rotate your IP address, you can rotate almost everything that comes from the client side. What are we now looking for? Mind you, don't always expect that all your requests will come from the client side. If you think that all your users are like anybody that will go and open a website and will continue using this, you are lying to yourself. Because I myself, sometimes I don't use websites with their UI. Most times I use them based on their API. I can go and scrape their API data and be using it to log in and log out and do whatever I want to do, because I know how to go about it. Now, if I had that kind of know-how, that means that I can go and find your backend server. So your front end doesn't even mean anything to me again. And this has happened several times where the front end has rate limiting, strong rate limiting, but the backend doesn't have any rate limiting. API doesn't have rate limiting. So that means I can walk into your API and nothing can happen. What about best practices? You have to look at best practices as well. For every single person in this world, every single person, no matter how skilled or unskilled you are, there are some practices that should be there in software engineering, especially in the modern day. I should be watchful and wary of. They are not even advanced experts. They are simple things that anybody can learn, but they are very, very important. For example, why am I saying that there is a 4-digit OTP in your system? Mind you, a 4-digit OTP can be brute forced in less than 10,000 seconds. In less than 10 minutes. A 4-digit OTP would have about a 4-digit OTP will have about 10,000 characters in them. If you now use your system CPU speed, by the time you look at it, you are looking at an attack time of less than 10 minutes. That means it takes less than 10 minutes to crack your password or change your password. And this is a very funny thing, but it leads to a lot of account takeovers. Now, imagine you wake up in the morning as a client in a financial company, and you wake up and the first thing you are seeing is that somebody has taken over your account and they have drawn all your money. How? You don't know. But you slept off overnight, and the next thing somebody changed your password without you even knowing anything about it. Why? Because of a 4-digit OTP. It takes way longer to crack a 6-digit OTP. That means that if you set your system for about, let's say, 5 minutes to expiry of the token, I can crack 4 digits within 5 minutes. It's not that long. But if you now try the same thing with 6 digits, it will take a longer time. You're looking at about 100,000 parameters in that span of time. You will not be able to do it. Even if you are able to do it, it takes a lot of compute and abilities, and your system might even crack before that happens. So these are basic things that they occur in our. That's why I keep saying it again, and I'll come back and say it again, that we shouldn't see the OWASP top 10 as the grand audit or the greatest, because instead you should be looking at the logic of the application that you're working with. You don't need the OWASP top 10. All you have to do to make the system do something that shouldn't be able to do. When you go into an application, you're looking at what you should not be able to do at all, and then you are doing it. So you will test and test and test. There are different funny things. There are a million and one funny things that you can test in this life, and you never get tired, you never get bored. But the moment you're able to tackle this, you have tackled every other thing that you want to tackle. Most of your system, most of your work is done. Are you with me? So I think with that, I think my final point to everyone would be that go back to OWASP top 10. 1 second, please.
Good evening, Mr. Emmanuel. Alpha.
Can everyone hear me?
Yes, sir.
Yeah, we can hear you, Mama.
So I was going to finish with this. Uh, I think you should go back to your OWASP top 10, both developer and security engineers. Go back to OWASP top 10. Um, Look through it, both API, mobile, and web, wherever you are. Look through it one after the other, and now visualize them in systems, which is why it's very, very helpful that you practice these things. They will appear differently in different systems. The only thing that will save you is your deep and core understanding of these bugs. Once you're able to understand what the core of this bug is, and not just the bug in itself, but like what the core is, why does it happen, what does it happen with, you cannot apply different bugs to different places. Where you should be doing an idle, you can't be doing an SQL injection there. You can even try, but you are only wasting time. And in the real world and in the real entity, nobody has time. You are given 2 3 days to pen test an application, and even the first day you have the only SSL opening and bypass alone has taken the whole of the day. So I think that would be all for me. If there's any question from anyone, you can ask now. I think I'll leave the floor open for any questions.
Good evening, Mr. Emmanuel. Thank you very much for the session. It was a very interesting one and insightful one. So, um, okay, we have a question here.
Let's go on with the question.
Okay, the question is the CI test and automation? Do you have suggestion of a CI methods to actually find security leakage in API, especially the input validation and authorization. I do authentication on CI, and the authorization is like quantum pieces to GitHub actions. Please, did you get the question?
Are we talking about CI/CD here?
I didn't get that.
Are we talking about CI/CD?
Yeah.
That's the pipeline that handles. I don't think there's anything. Perhaps I don't think there's anything in the sense that can keep you from these issues, unless you have a very good developer. Reason being that you can write 1,000,001 tests to be run before the application goes live and to test it. But the honest truth is this: 1,000,001 tests will not stop these bugs from appearing. For example, you can write a detailed test that tests over a set of parameters. In the honest truth, those parameters may never be used when they want to exploit you. It might be the weirdest and funnest parameter that we use against you. So how do you not prepare against that one? That's why there's a need for safe development practices. That means like you are developing, you develop safely. Are you with me?
Yes, we
So
are.
I think the bulk of the work for or input validation comes from the comes from the comes from developers angle.
Please,
Sorry.
can you mute your mic?
Yeah. Okay. Like I was saying, I think the bulk of it comes from the developer's angle. So if the developer is able to curb all these things, because it should not even be the work of the security engineer or the DevOps engineer to be searching for those kind of flows. That's why I said different kind of flows have different kind of places that they manifest. So you can't exactly pin it on CI/CD alone. Well, okay, what test you want to write for parameter pollution? Fine, there are ways to write tests for SSRF and all this, but what about the others? Fine, there are some that you can test for. You can try and test them yourself. You'll be testing individually, and mind you, in enterprise applications, you're looking at a very large scope. So how many units do you want to test? How many user input parameters do you want to test? So that's why I say that the bulk of it comes with the developer knowing, understanding secure development practices. I don't think it relies on the CI/CD pipeline. Any other question?
Good evening, sir.
Good evening. Please go on. And please don't panic, sir.
Sir, so can all of this be done on the phone? Like, are there application I can use to do all of this on my phone?
If I'm being honest with you, please can you mute your mic?
Okay.
If I'm being honest with you, I don't think that you can. I don't know what you mean by all of this. Let's be honest, because all of this is a very large term. In here, we are talking about software development and we're talking about some key aspects of web security or web and API security. So, can you practice web and API security with your phone? I highly doubt it. I don't think so. Fine, there are some
Okay,
things
sir.
that there are some things that you can do with your phone, but in the end, it doesn't allow you explore as deep as you should explore. So I don't think it is a a good deal to do all of this with a phone.
Okay, thank you very much for answering the questions and thank you for the section as well. So we'll be moving on to the third section, which is the fireside chat. And we have here with us Mr. Joshua. Is a penetration tester and is also the CEO of Hybrid Self Consult. So I'll be asking a few questions from him. And also, if you have any question, you can kindly drop it in the comment section, and I'm going to absolutely have. So my first question will be: we all know we are in the age of AI, and a lot of people use AI to code. Now, what can you say about coding with AI? Does it introduce more vulnerability in your system, or does it help with the security aspects of the system? Like, how does it affect the security aspects of building an application?
All right. Good day, everyone. I'd like to introduce myself once again. Um, my name is Joshua Birufwem. I'm a penetration tester and founder of Hybrid Security Consult, but I go by Haruki. I'm Coco Felon. Hi. Yeah. So I go by Haruki. Can you come again with the question?
Okay, the question is about AI used in development. How does it
Okay.
affect the security aspect of developing a modern application?
All right. It depends because there are actually two sides to this, right? Um, there are people that are software developers and there are people that are vibe coders. Now, vibe coders with the software knowledge and security is a plus. Why normal vibe coders that are just coming up in the industry, this is where the flaws are, right? So, like I always say, that AI has come to stay, and developing with AI makes the task easier, right? But many people develop with AI without understanding security, and that's where the flaw is, right? A lot of people develop applications. I've seen a lot, and in within few hours you found bugs. Like, in fact, some of them you can even dump their database. That's how crazy it is, right? So AI has come to stay, and developers need to understand the concept of security in this AI age. Yeah, and that is what is really going on, is trending. And how does it affect security posture, right? When you build with AI, you can just tell AI to develop a particular website, maybe front end, back end. AI will just develop you a lot of codes, right? We can use Claude, we can use this, we can use that, right? We can use Codex by ChatGPT and all of that. But one where the problem is that people don't actually check what they actually develop, like in terms of security. So there was a day until, I don't know, it was popular. A forex trader in Ghana said, "Wow, he's building sophisticated website," and he came online and said hackers should penetrate his website, give him free pen test and all of that. And looking at the website, it was beautiful, honestly, looking fine, all flashy. But in less than couple of, like, 2 3 minutes of testing, I've already found up to 10 bugs, including his database, including his ordering idol, and a lot more. So developing in this AI age, right? There's If you're developing as a developer without security, that's where the real problem will be. So yeah.
Oh, what the fuck? Can you hear me, please?
Yeah, I can hear you. Moshood,
Okay,
Moshood.
okay. Thank you for that. Now, my next question would be: how important is security for developers? Like, how deep should they go into security when they are learning web development? We've learned about the different vulnerabilities and how they can be exploited. So, before a security engineer can work on an application, how deep should a developer learn about the security of the application, and how can they learn it? So that's the next question.
Number one issue is understanding code logic, right? So we contracted a developer to develop our own website for our company. And after doing our code review, we discovered that people can actually, instead of paying for our service, people can actually boycott that. And yes, they can boycott the payment and it will approve it. And it was going to, like, it would be as if they paid. Meanwhile, they haven't. And this particular bug was lying in the code logic. Do you understand? So as developers, you must understand your code. When you put this in place, you have to read that code and understand what the code is doing and how attackers can bypass that, right? So number one, Q&A. But still, even as developers that develop, I've seen a lot of developers that follow the OWASP Stop 10 as a guideline in ensuring this thing. But honestly, as Coco Fellon has said, right, in fact, outside the OWASP Stop 10, I've learned to look outside the OWASP Stop 10, right, and how and how and I've learned to look into the CIA triad. Yes. When you're looking for a bug, right, I don't go with the concept of, okay, OWASP Stop 10, this is OWASP Stop 10, right? This is it. And that's how it is. I'm going to look for bugs like this. And it's going to limit you to see things, right? So I was hunting on a Chinese platform and I discovered a bug that can allow me delete users' accounts, right? So, and if you check the OWASP Stop 10, there's no bug that is like that, right? And if you look at the CIA triad, we have confidentiality, availability, and integrity. So at that moment, for that organization, right, that bug that I found is actually causing them availability of their customers and loss of account. So when Coco Fellon said that you should look outside the box, think outside the box, but just use it as kind of a guide. But there are other bugs you can find outside the OWASP Stop 10 that are very, very crazy. So instead of using the OWASP Stop 10, but have it in your mind that, okay, you can encounter this, right? But outside the box, always look for something that can compromise the confidentiality, integrity, and availability of a particular platform to either the platform itself or the end users. Are you getting me? So this is the concept. So now, how deep does a developer needs to go? Developers need to understand their code, right? Developers need to understand their code, right? Okay, hold on, please. So developers need to understand their code, and that's very, very developers need to understand their code, and that is very, very, very important in today's world. Then you can also use the OWASP Stop 10 framework in your dev SDLC, like your development lifecycle. Know where bugs can do that. Then leave the rest to security engineers or pen testers like me. That's all.
Okay, thank you for that. Now, the next question will be about going into app security. Now, we have some web developers that are also looking into going into app security. Do you think it's actually a feasible thing, juggling web development and app security?
All right. Yeah, it's important. I know people that are doing both, right? A better web developer understands security much better and how it pertains to them, right? So if you've been developing for a long time, you understand security depth, where are the endpoints that can possibly leak out information, compromise confidentiality, integrity, and availability of whatever service you are running to your listen. You also know about API API leakage, like hard coded credential leakage, right? At specific endpoint. So these things are important. Yes, as developers that are doing security is a very good thing, right? So even me, when I started, I didn't have the concept of how application works at first, right? But as I started developing things, I started to understand where and where leakages can come in and all of that. So as a developer transitioning into security or juggling both, yes, it's a win-win.
Okay, my next question will be based on oh, sorry for that. Okay, you've been working as a penetration tester for a while now. Now, what are the most minute vulnerabilities you've actually encountered in an application that you felt like this could have actually been avoided by the
All right.
developer?
So far so good. My first vulnerability in an application was a um, was admin bypass leading to full admin account compromise. Yeah. So this is when this application was giving me admin access without verification, but from um it does that from yeah, when you force for a specific directory like admin and so many other bugs, right? Once you force for admin, it gives you that admin session token, right? It for a few seconds, it logs you and authenticates you from this thing. So what I did was I swapped my own token and put the admin token there, and I had full access, right? So it was maintaining that admin session for a much longer period. Yeah. And so many other bugs. We found cloud misconfiguration, S3 bucket misconfiguration, leading to downloads of users' data, um, SQL injection, and yeah, and vulnerability keep progressing as I get more experience. Arbitrary file upload and more. Yeah.
Okay, thank you very much. That will be all for the questions. Now, what would you like to say to us as developers and cybersecurity analysts?
All right. In all you're doing, don't give up. That's the thing I'll tell you. Keep being persistent. As a hacker, sometimes it's discouraging. Yeah. Um, yeah, hunting, finding vulnerabilities and all of that. But one thing I would say for sure is that don't give up. Keep going. Yeah. Though it's wavy, security is a bit wavy in Nigeria, but keep going, keep pushing, and keep finding. Yeah, keep attacking, keep finding, keep gaining more experiences, and with time you become good at what you do. So that's the piece of advice. And as developers, always learn to build a security mindset. Don't push products to the online and expect people don't push products online except you've properly tested from the SDLC, right, from your development life cycle till when that product is ready to like for the market. Testing must be done. Take security must not be a second thought. Right? Most Nigerians have this concept that build your application, launch it into the market, and yeah, how enjoy your application. Every moment and every second that you launch an application to an online platform that is visible for people to see, yeah, yeah, it's a ticking time bomb if security is not implemented. So always make sure security is there at every standpoint, because let me tell you, there are a lot of things that people can use data information to do, and it is very, 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 very crazy, including it has led to so many people dying. Yeah, that's data privacy and data exposure has led to so many people dying. I've seen a case whereby they hacked into this hospital therapy relation app, and boom, next thing the attacker started leaking all the secrets, and some people at some point were fed up and committed suicide. So these things are real time. So if you're building application, make sure security is the core value. Why from the grassroots to when you are building to coding to deployment and into production, when you are shipping everything into production, make sure security is like you have that security mindset. So peace and love, Ashka.
Thank you very much for joining the call and thank you for answering our questions. And thank you everyone for joining as well. I know this it has been an interesting one, right from the beginning, from the software engineer to the security engineer and then to the penetration tester. So if you have any question, I think you can ask the question now. And if you don't have, in the absence of no question, we have to end the call. Thank you very much for joining. And before I end, I want to implore you all to keep security in mind when you are building an application. Every application needs to be secured. There is something I saw online recently. Security is expensive until you are breached. When you are breached, then you know the expenses of you. I think the software engineer talked about that the first time when he talked about um an application that someone built that was asked a financial application. Now, not only financial application needs to be secured, any application that you are collecting user data needs to be secured. I was having a conversation with a friend one time and he was telling me the kind of data he's collecting from user. And I asked him, do you have any security person working on these applications? He said no. And I was like, how can you collect this kind of data from people and you don't have a security person working with you? You don't have any idea of what security is. You are just building an app, collecting this kind of data from people. So when you're collecting sensitive data, when you're collecting PII, make sure you have a security person with you. Even if you don't, try to learn a little thing about the security and integrate security into your development because security begins from the developer. It's not only the work of the security analyst. So that's all we have for tonight. Thank you very much. Thank you for joining the call. It was an insightful one, and I hope you have another one next time. I'll be seeing you later in the next. I think our webinar should be bi-weekly or weekly, yeah.
Have
So
a
we'll be
great
seeing you
day,
later in the
everybody.
next webinar. What did you say?
Have a great day, everybody. Caleb, okay.
Yeah, yeah. Thank you for joining.